Okay, so let's talk about a paper that basically dropped like a bombshell back in early 2023. It came from Meta AI, and it completely blindsided the entire world of artificial intelligence. See, it wasn't about building the biggest model, but it might just be the most important one. Today, we're going to break down LLaMA, the foundational model that really kickstarted a revolution. Let's get into it.
So this is really the core of the story, right? The big question that makes it all so fascinating. At a time when absolutely everyone was in a race to build bigger and bigger and bigger models, Meta comes along and releases LLaMA. And its smallest useful version was over 10 times smaller than the reigning champ, GPT-3. So how in the world did this underdog manage to pull that off?
To really get why LLaMA was such a big deal, you gotta rewind a bit. The years between 2020 and 2022, well, we can call that the age of giants. The name of the game, the whole philosophy, was an arms race for more parameters. GPT-3 kind of set the bar at 175 billion, then Google's Palm just blew past that. The thinking was really simple. Bigger is always better, period.
Yeah, but here's the catch with these giant monster models. There was a huge problem, and it all boils down to this thing called inference cost. You see, it's one thing to spend a ton of money and time to train a model once, but it's a whole different ballgame to actually run it every single time someone needs a response. The massive size of these things made them ridiculously expensive and just too power-hungry for anyone outside of a handful of giant corporate labs.
And this right here is where the LLaMA paper just completely flipped the script. The old philosophy was, you have a compute budget, you pour every last drop of it into making the model as big as you possibly can. But LLaMA's philosophy was kind of backwards, in a genius way. It asked, for a given model size, what if you just train it on way more data? I know it sounds almost obvious now, but at the time, this was a seriously groundbreaking idea.
You know, the paper itself puts it perfectly. They basically said, look, for anyone who wants to actually use these things in the real world, you don't really care how long it took to train. What you care about is how much it costs to get an answer, day in and day out. Their whole argument was that a smaller model, even if you have to train it for longer on a ton more data, ends up being way cheaper to operate when you're using it at scale.
Okay, so that's the what. Now for the how. How did they actually build this giant slayer? Well, the secret sauce was all in the training regimen, and they built it on a foundation of data that was exclusively public, a decision that, as we'll see, had massive consequences.
Take a look at this. This was LLaMA's diet. And their data strategy was a huge piece of the puzzle. Unlike their competitors, who were using all this private, locked-away data, the LLaMA team built their model on 1.4 trillion tokens scraped from the public web. You can see the breakdown, a huge chunk from Common Crawl, but then they mixed in high-quality stuff from GitHub, Wikipedia, and Archive. This was a really big deal because it meant their work was completely reproducible.
But, it wasn't just the data. The team was also super smart about the architecture. They grabbed a few clever ideas that were floating around from other recent models. They used stuff like pre-normalization, which helps keep the training process from going off the rails, the Swigloo activation function to squeeze out a bit more performance, and rotary embeddings to give the model a more flexible sense of word order. Now, none of these were brand new inventions on their own, but when you put them all together, man, it made for one incredibly efficient model.
All right, and this is the showdown. The moment of truth. This table from the paper is where they put LLaMA up against the giants. And the results? Honestly, they were just stunning. On a whole bunch of common sense reasoning tasks, the tiny LLaMA 13B model, that's the 13 billion parameter one, was consistently outperforming the 175 billion parameter GPT-3.
Let that sink in for a second. More than 10 times smaller, while being better on most of these benchmarks. This wasn't just a small step forward, it was a total game changer. It meant you could suddenly run a model with the power of GPT-3 on a single high-end GPU. And that was something that was just completely unthinkable just a few months before this paper came out.
Look, the technical results were amazing, for sure. But the real legacy of LLaMA, the thing we're still feeling the effects of today, is what happened next. By building on public data and then releasing the model weights to researchers, LLaMA didn't just publish a paper, it lit a match and started a movement.
You can almost see the chain reaction happen in real time. First, the model weights get released to researchers. Then boom, suddenly these state-of-the-art AI models aren't locked away in some corporate vault anymore. And that just lit the fuse on this Cambrian explosion of open source AI innovation that we're still riding the wave of today.
So that brings us to the future. LLaMA taught us that training on more and more tokens is absolutely key. But what's the next frontier? The legacy of this paper inspires a really fascinating question. What if the next big leap isn't about more data, but about perfect data?
Just think about this for a second. You could use LLaMA's super efficient architecture as a kind of standard testbed, right? And instead of feeding it trillions of random tokens from the web, what if you trained different versions on much smaller, perfectly curated, maybe even synthetically generated datasets? The goal would be to find the most information-dense tokens, the ultimate curriculum for pre-training an AI. It really makes you wonder, could a model trained on, say, 100 billion perfect tokens actually smoke a model trained on 2 trillion noisy ones? Thanks to LLaMA's efficiency, that's a question we can actually start to test.
So in the end, LLaMA was so much more than just a better model. It gave us a whole new blueprint, a new way to think about how to build these things. And that is a legacy that is absolutely shaping the future of AI. This is for entertainment purposes only.